Alright, today we're looking at factoring binomials. Just like all the other classes, we're going to talk about the steps for factoring a binomial, then we'll do some examples and you'll be on your own. Today, as long as you know your perfect squares, so like I said last class, your perfect squares are 1 times 1, 2 times 2, 3 times 3, 4 times 4, so on and so forth. So those perfect squares, anything times itself. Okay, so step 1, just like the other two class periods, we are going to look for a greatest common factor first. So that's your GCF, greatest common factor. Okay? Once you find, if they have a greatest common factor, you'll pull that number out, divide each of your terms by whatever number of variables that you've pulled out. The second thing you're going to want to do is check for a difference of squares. So this is something new, and we will see some examples of this. Difference of square. What this must be is it must contain perfect square coefficients. So whatever numbers in front of the variable, that must be a perfect square. It must be subtraction. So you'll need to have a minus sign. And your exponents on any of the variables must be even. If it does not satisfy those three things, A, B, and C, then we don't have a difference of squares. Once we check for the first difference of squares, if you can factor it, then you need to check for a second difference of squares. So we want to see, are one of the factors that we just got, are one of those another set of difference of squares? Okay, and then if you check these three things, 1, 2, and 3, and none of that is true, then the binomial is prime. Okay, so like we said before, if you can't do anything to the binomial, it will just be prime, and you leave that as your answer. Okay, so let's look at some review problems before we get started. So this is just review of factoring out the GCF, the greatest common factor. So look for similar coefficients that are divisible at the same number, and then look for variables that you can pull out from each term. So in number 1, if we look at our coefficients 3, 6, 18, what are all those divisible by? Hopefully you said 3, so we'll pull out a 3. Now look for variables. So what are these variables? We've got an x, a y, and an xy. So obviously we don't have an x in the middle term, and there's no y in the first term, so we can't take out any of those variables. Those will stay. So now we go through and divide each term by 3. 3 divided by 3 is 1, keep the x, plus 6 divided by 3 is 2, keep the y, and 18 divided by 3 is 6, keep the xy. Okay, so that is factored. If you want to go back and check, remember, just distribute the 3 back into all of these terms. I'm not going to do that now, but you can always check your work. Okay, our second problem. We've got AB plus AC. So these are all variables. See if both of those terms, what can we take out of both terms? Obviously the A. So we'll have A times B plus C in parentheses. And then our last one, 12x cubed y to the 4th minus 6x squared y to the 7th. So looking at the 12 and the 6, both divisible as 6, so we'll pull that out. We've got x to the 3rd and x squared. We'll pull out an x squared. Y to the 4th times y to the 7th, we'll pull out a y to the 4th. So 12 divided by 6 is 2. X cubed divided by x squared is x. Y to the 4th divided by y to the 4th is just 1. So we leave it there. Minus 6 divided by 6 is 1. We don't need to write that 1. X squared divided by x squared is 1. Then y to the 7th divided by y to the 4th would be y to the 3rd, because we're subtracting those exponents. Okay, so we practiced, reviewed, pulling out that greatest common factor. Now let's get into our perfect squares. So first thing we're going to do, always look for that GCF. Then let's look for our difference of squares. We need perfect square coefficients, subtraction, and even exponents. So let's take a look. Okay, in number 4, first we look for the GCF. Well, I know the only factors of 4 are 1, 2, and 4. The factors of 25 are 1, 5, and 25. So there's nothing in common there. Okay, so now we need to check for perfect squares. Is 4 a perfect square? Hopefully you said yes. And then is 25 a perfect square? Again, hopefully we said yes. Okay, so we've got step 2, part A. We've got perfect square coefficients. Now we need to look for subtraction. All right, we've got subtraction, and then we need to look to see, are the exponents even? Yes, exponents are even. So those 3 things are satisfied. So to get our 2 binomials that multiply to equal this, it's very simple. So I'm going to go ahead and write my bracket, my parentheses for my 2 binomials. Perfect square, 4. 2 times 2 gives me 4. So I know the coefficient in front of my x's will be 2. All right? Then we know perfect square of 5 is 5 times 5. Okay, notice in these perfect square binomials, there's no middle term. Okay, so typically we have a trinomial with a middle term. Here we just have a binomial. So that means the middle term is canceling out. And for that to happen, we're going to have a minus 5 and a plus 5. And those would be our 2 factors. So let's check this and see why that happens. Okay, so 2x times 2x is 4x squared. Then 2x times 5 is a positive 10x. Negative 5 times 2x is a negative 10x. Negative 5 times 5 minus 25. So notice here in the middle, negative 10 minus 10, positive 10 minus 10 cancels out. So then, I need this to go away. So then we are just left with the 4x squared minus 25. And that is what we started out with. So whenever you have your perfect squares, you're subtracting and your exponents are even, all you have to do is take the square root of your 2 coefficients and then put a plus 1 and a minus 1 of them, and that's your answer. Okay, so for number 5, the coefficient in front of x squared, y squared is 1. That is a perfect square. The square root of 1 is 1, so that's a perfect square, and all of our exponents are even. So we're going to write our 2 binomials, xy, 1, xy, 1, plus and minus. And that's our answer. Remember, xy times xy would give us the x squared, y squared. That'd be minus xy plus xy minus 1. So that matches the original. Okay. Number 6. 81 is a perfect square. 16 is a perfect square. We've got subtraction, and we have even exponents. So we know that this is a difference of squares. So the square root of 81 is the square root of 81 is 9. X to the 4th, the square root of that would be x squared. We would want minus, the square root of 16 is 4. The square root of y to the 4th would be y squared. So now we're going to write that same binomial, but with a plus sign. So 9x squared plus 4y squared. Okay, here's a good example. Check both of these binomials. Are either one of these binomials still a difference of squares? So are the coefficients perfect squares? Are the exponents even? Do we have subtraction? Hopefully we see that this first one is another example. So we can actually now complete these steps one more time. So this would factor out into 3x minus 2y times 3x plus 2y. And then you always need to keep what we originally had. So we need to keep the 9x squared plus 4y squared. And that entire thing would be our final answer. Okay. But sometimes, if we look at 7 and 8, notice we're going to factor out the greatest common factor. Then we're going to have to take the difference of 2 squares. So in number 7, we've got 18x squared minus 8. Those are obviously both divisible by 2, so we can rewrite that as 2 times 9x squared minus 4. Okay, so now in our parentheses, we've got the difference of squares. So we need to still simplify that further. You keep the 2 on the outside. 3x minus 2, 3x plus 2. So the square root of 9 is 3. The square root of 4 is 2. And there is our final answer. So take the square root of your first coefficient, the square root of your second coefficient. Okay, let's try that one more time. Remember, we want subtraction in here. So whenever we take out our common factor, we need to make this a minus. We need to take out a negative. Let me get rid of that arrow. There we go. Okay. So our greatest common factor is going to be a negative 3. Check your variables. Okay, we can't take out any variables. So here we will have y squared minus 9x cubed. Oop, no, not x cubed. Why did I write that? X to the 6th. I was jumping ahead. Okay, so check your coefficients. The coefficients are perfect squares. We've got subtraction, and our exponents are even. So yes, we can factor this one more step further. Keep the 3 on the outside. We'll have y minus 3x to the third, y plus 3x to the third. Remember, we want our exponents to be even, and when you take the square root of that, you're just dividing it by 2. So 6 divided by 2 gives me the x cubed and the x cubed for those x's. Okay, check to see if we have a second difference of squares. Nope, because there's not even exponents. No even exponents or a minus sign. So our final answer would be 3 times y minus 3x cubed, y plus 3x cubed. Okay, then some special cases here. So looking at number 1, I see our coefficients are perfect squares, 1 and 16. I see even exponent, we've got x squared, but then this is a plus sign here. Okay, so A, B, and C, our 3 rules are not met. So this is an example of a prime binomial. We cannot do anything to that. All right, and then 10, we've got the 4, the 11, there's nothing common there. 4 is a perfect square. 11 is not a perfect square. Also, we have a plus sign here. That's not okay. So this is another example of a prime binomial. All right, so those are our notes. Hopefully we could see what was going on. You want to have those 3 rules memorized when you see a binomial. We want to look for, oh goodness, sorry, there we go. We want to look for perfect square coefficients. So that was 1, 4, 9, 16, 25, 36. Okay, so all of our perfect squares. Then we want to look for subtraction. So our first term minus the second term. And then you want to look for even exponents. Those even exponents will always be with your variables. Okay, once you do those 3 things, you then want to go and check for a second difference of squares. So then you would be repeating those steps. Okay, and then if you can't do any of that, then you have a prime binomial. So if you will, pause this video and work on We'll just say the first 6 triads on your own. Then unpause the video and check your answers. Okay? So pause the video now and then work through the problems and check your answers once you are done. Here are the first 6 answers. None of these were prime. I will say in number 5, you didn't have perfect squares, but you could pull out a common term. So that one is not prime. We can factor it, taking out that greatest common factor. So just always make sure you're checking for that GCF first, then work your way through the problem. Okay, so that's all I have with this video. If you want to do the rest of the triads in your free time, those answers are in Google Classroom. You can always work on those now or at home. Go ahead and you can stop the video, and the rest of the directions for the rest of the class period are on your board. So rewatch this video if you need to, refer back to it if you need help with the rest of the activities during class. And if not, I hope you'll have a great rest of your day.